this question asks us to find the intercepts of the cubic function f of x equals x cubed plus 27. So whenever you're trying to find the intercepts of a function, the quickest way to do it is to graph the function in Desmos. So if I zoom out, I can see the places where the graph crosses the x-axis and the y-axis. And all I need to do is click on them to get the coordinates. So you can see here it has an x-intercept at -3, 0. So I can go ahead and eliminate actually all answer choices except A. And let's just verify that the y-intercept is 0, 27. So that's going to tell us that A is the correct answer. So here it says f of x equals x cubed is transformed to g of x equals x minus 4 cubed minus 2. So let's describe how the function has been transformed. So if we look at here, what's been changed from the parent function is this x minus 4. So this x minus 4, if we look at our chart, that means we have a shift right when we have an x minus h. So x minus 4 is going to be a shift to the right 4 units. Also notice what's changed in this new equation is we have this minus 2 on the outside. So our chart tells us that we have a shift down when we have a minus k. So minus 2 means we have a shift down 2 units. So here we have a shift right 4 and a shift down 2, which is answer choice B. Remember, we can always verify by looking at the parent function and the graph of the transform function. If we pick a point like 0, 0, and we compare how it changed, notice it went to the right 4 and down 2 units. The parent function f of x equals the cube root of x is transformed to g of x equals 7 cube root of x plus 2. So we're going to use our usual strategy to identify the transformations. We're going to identify what's been changed from the parent function. So here we have the 7 in front. If we think about it, the absolute value of 7 is equal to 7, and that is bigger than 1. So that means we have an a that's bigger than 1, and so that is going to be a vertical stretch. Okay, so that's going to be the effect of that 7 in front of the cube root. Now notice we have an x plus 2 inside our root. If we go to our chart, it says we have a shift left when we have an x plus h. So that x plus 2 is going to be a shift left, and it's going to go 2 units. Remember, we can always graph the parent function. So you can see here the parent function in black and the transform function in red. Notice that it is vertically stretched, and also notice it's been shifted to the left 2 units. We would say vertical stretch by 7 and a horizontal shift left 2 units. This problem, it says to identify the graph of f of x equals the absolute value of x minus 3 plus 5. So whenever you're doing these graphing questions, make sure that you're using Desmos. So what I would do here is go ahead and enter the function f of x equals the absolute value of x minus 3. And then remember the plus 5 needs to go on the outside. So what happens here is you want to identify the key features of this function and use it to match to the correct graph. So notice I'm looking for a graph that has a vertex at 3, 5. So if I look at these choices right here, notice that this one does have a vertex at 3, 5. So this is looking pretty good. This one has a vertex at 5, 3. So B is not a good choice. C has a vertex at 0, 5. So that's not a good choice. D has a vertex that looks like -5, -3. So that's not going to be a good choice either. I'm also just going to double check, like for example, see here, I have a y-intercept at 0, 8. I want to make sure that the graph I chose has that same feature. And if I look here, I can see that it does have a y-intercept at 0, 8. So I know that A is the correct answer. In this problem, it says the function f of x equals the absolute value of x undergoes a vertical compression by 1/5, horizontal shift left 3, and a vertical shift up 4. So what I'm going to do is I'm going to identify each transformation and then whether that's a value of A, B, H, or K before I write my equation. So it says vertical compression by 1/5. So a vertical compression means I have an A that's between 0 and 1. So I know this is going to become a value of A. Horizontal shift left 3 units. If I go to my chart, it says left when I have an X plus H. Okay, so I know that left 3 is going to become an X plus H. And then it says a vertical shift up 4 units. If I go to my chart, it says vertical shift up when I have a plus K. Okay, so now I just need to turn these into an equation. So I have A is 1/5. I have an X plus H, that's going to be an X plus 3. I have a plus K, that's going to be a plus 4. So when I write the equation, I have g of x equals 1 over 5, because that's the value of A, and then the absolute value of x plus 3 And then I have my plus 4 on the outside. Okay, so if I match to the answer choices, it's going to be answer choice A. Remember, you can always verify by graphing the parent function and the transform function in Desmos, and you can see that the purple graph is in fact vertically compressed because it's wider. It is shifted to the left 3 units, and it has gone up 4 units. Ask me, what is the equation of the square root function represented in the graph? So to identify the equation, I'm going to notice some key features of the square root function shown in this graph. Notice it has a minimum value, and that value is at 3, -4. Okay, so whatever equation is going to need to match that characteristic. Also, notice that this has an x-intercept at 19, 0. Okay, so whenever I type these equations into Desmos, I'm going to make sure that whatever graph I choose has the same features. So what I've done over here is I've typed in all the answer choices into Desmos, and I'm going to go ahead and hide these so we can look at them one at a time. If I look at this first graph right here, we'll notice it has a minimum at -3, -4. So we know that's not going to be the correct answer. If I look at this second graph right here, notice it has a minimum value at 3, -4. And if I look at the x-intercept, that is at 19, 0. Okay, so I'm thinking answer B is probably going to be the correct answer, but let me just look at the other graphs to be sure. If I look at C, well, that minimum is at -3, 4, and it has a y-intercept, which is not similar to our graph. If we look at the last one, notice it has a minimum value at 3, 4, and actually this graph doesn't cross the x-axis. Okay, so that's why we know B is the correct answer choice. Question asks how g of x equals the square root of x plus 6 has been transformed from the parent function f of x equals the square root of x. Notice what's different in the transform function is we have this x plus 6. Our chart tells us that that's going to be a shift left. So I'm going to say that's going to go left 6 units, which is going to be answer choice B. But let's go ahead and go to Desmos and verify that that is correct. You can see the black graph is the square root of x, so the parent function. The red is the transform function, and it is in fact shifted to the left 6 units. Let's look at what is the effect on the graph when the parent function f of x equals 2 to the x is transformed to g of x equals -8 times 2 to the x plus 5. So the first answer choice says the y-intercept becomes 0, -3. Well, what I've done here is I've graphed the parent function and the transform function in Desmos. So I'm going to look at the transform function in green, and you can see here it does cross the y-axis at 0, -3. So I'm thinking that's a pretty good answer choice, but I want to check what else it says. It says the horizontal asymptote is y equals -8. Well, that's not going to work because if we look at our graph, you can see that the green graph has a horizontal asymptote at y equals 5. How do I know the horizontal asymptote needs to be at y equals 5 without looking at the graph? Remember this value of k, y equals k is going to be our horizontal asymptote. So we can tell that it's going to be y equals 5. So B is not a good answer choice. The graph is vertically compressed. Well, if we look at the transformation, we have a -8 in front. The absolute value of -8 is equal to 8, which is greater than 1. So, in fact, this graph is going to be vertically stretched. Okay, so it's not going to be vertically compressed, it's going to be vertically stretched. And then it says it shifted right 5 units. There's no change inside the exponent, so this graph is not shifted to the right. This plus 5 is on the outside, and that's a value of k. So that means the graph is going to be shifted up 5 units, like you can see here from Desmos. So that means that A is the correct answer. The y-intercept becomes 0, -3. It says what equation describes the horizontal asymptote of the graph of f of x equals 3 to the x plus 4? So there's two ways you could figure out the horizontal asymptote. First, you could do so by looking at the equation and remembering that y equals k is going to be the equation of the horizontal asymptote. So in this case, that's going to be y equals 4, which is answer choice A. You could also figure it out by looking at the graph and notice that as the graph approaches y equals 4, the x values head to -infinity. So that kind of behavior means that we're going to have an asymptote at y equals 4. And so you can figure it out from the graph also. This question asks which graph represents the logarithmic function f of x equals log 5x plus 3 minus 4. So whenever we're doing the graphing questions, we want to always use Desmos to help us out. What you can do is graph this equation in Desmos and look at the key features of the graph. So notice this has a y-intercept here at -3.5. So what we can do is look at our graphs and see which one has a y-intercept that matches. So A looks good. B doesn't even have a y-intercept, so we can eliminate B. C also doesn't have a y-intercept, so we can eliminate C. Okay, so we have to figure out whether A or D is the correct answer. Well, another characteristic of logarithmic functions is that they have a vertical asymptote, right? So you can see these values here, they're somewhere between 0 and -1. This graph has a vertical asymptote, okay? So it doesn't go past -1. So if I look at my graph, notice that this one, answer choice D, it does go past -1. That asymptote is actually, it looks like it's at -4. So that's why we can find that A is the correct answer. Remember, you can also find the location of that vertical asymptote by setting the part that's inside the logarithm equal to 0 and solving for x. So if we solve this for x, we can subtract 3 on both sides and we get 5x equals -3. We divide both sides by 5. X equals -3/5, which means that x equals -zero point 0.6. So that means this graph is going to have a vertical asymptote at x equals -0.6, which does match answer choice A.